So today we're on lesson 24, percent and rates per 100. I can understand that percents are related to part-whole ratios and that rates where the whole is 100. So this is going to be our last main idea that we explore in our ratios unit, is this idea of a percent. So you've probably seen percents many times in your life, like 10%, 20% off. So that's what we're going to be working on today. Percents are part to whole ratios. So they're going to be just like a fraction. So remember, a fraction is part to whole. The only difference is what? Well, we see this right here. It says the whole is 100. So in a percent, the part to whole is going to look like this. A percent equals some part over my whole, and the whole is going to be 100. That's all a percent is. Percent is a fraction or a ratio with 100 as my denominator. So let's begin. Imagine that you are shopping. You want to purchase an item for $100, but today it is 20% off. What does that mean? Well, it means that for every $20 you're going to save on 100. So it means that 20 out of every $100 will be subtracted from the total. So what does this mean? $20 will be taken away from 100. So it means we're going to subtract 20 from 100. So how can this situation be modeled? We have two methods. One is I can just create a tape diagram. So here I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. My whole tape diagram equals $100. And 20% off, well, that would be two of these boxes. So that means I'm going to save $20. Another way to model it is using a hundreds diagram, or a 10 by 10 grid. So what will this look like? Well, that certainly didn't go the way I thought it was going to. So let's look at it this way then. I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's another 20. So here, 20 of them are shaded in. How many total do I have? Well, I'm purchasing $100 worth normally. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10. And what does that equal? Well, that equals 100. So here I have 20 parts shaded, out of 100. So both of these are models that show 20% off of 100. So 10 by 10 grids are what we're going to be actually focusing on today. We should be good with tape diagrams by now, so we're going to be using our 10 by 10 grid for percents. So we're going to explore percents using a 10 by 10 grid and our problem on the previous page. So let's go to our website. So our problem is going to be the exact same thing. I'm going to look, I want to show what 20% looks like. Well, here, that's 10%. Here's 14. So here's 20%. So it looks exactly like our model here. What if I wanted to know if it was 80% off? So it's on clearance. What would that look like? Well, here is 66%. 78, 79, 80%. So this means I would be saving $80. Let's look at this though. Let me go all the way back down. What if I have two grids? Well, if I fill in one completely, that's 100%. 100 parts out of what? 100. And we should recognize this as being one whole. What if though I have 2% grids and I fill that in? Notice what happens over here. I still have one whole, but now it's an extra 14. So what would this be? Well, this would be the same thing. It's going to be my parts over my whole. So I have 114 boxes checked in, but it's still 100 to make a whole. Alright, let's look at this one instead. What would 66 look like? Well, that means I'm going to have 66 boxes filled out of 100. So let's just start here. 65, so I need to increase by 1, 66. Let's check our next one out, 92. So let's see, 17, 27. So 92 is going to be somewhere over here. 95, do these numbers match? No, it's still a little too big, so I'm going to go down a bit. 93, 92, still a little bit. So now let's check down one more. 92 to 92. Okay, let's check this. So now I'm looking for my percent. So I'm going to count my boxes up. I probably don't want to go like this. 1, 2, 3, 4, 5. All the way to this spot. So what I'm going to do is I'm going to count by tens. 10, 20, 30, 40, 50, 60, 70, 80. Did I go all the way to 80 though? No, I didn't. So I stopped at 70. Then I need to go 71, 72. So let's test that out. I have 72. So it didn't like that. So let's try this one. Do you like that one? Yep. Yeah, so here we go. So we can see percents, they're very easy to model when I am looking at numbers. And I'm using my numbers with my 10 by 10 grid. So let's look. If I fill all this in, that's going to be 100%. If I fill another box in, that's going to be 100 plus 100%. And then if I have this, I just count up my little number boxes, and that's 13. So here I have 100, 200, 200 plus 13. Alright, let's continue back to our regular lesson. Alright, let's watch this short little video.
You might have heard people talking about percents. Someone might have said to somebody, hey, I want you to give 100%. That means give it your all. Or you might go into a store and see 50% off, which means half the price. Well, it turns out that we can actually think about percents mathematically if we're careful and understand the definition. Let's start with an example to indicate what, in fact, a percent means. Well, a percent is just what amount of 100 we have. So 12% means 12 of 100. So if we were to visualize 12%, we could think of 100, let's say 100 squares. This is a 10 by 10 grid. And 12% represents 12 of these squares. So I could actually color them in if I wanted to. And I could color them in by just taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so I'd color in all of these. Now maybe you're better at coloring in than I am. I'll do my best. But the point is we can see how many of 100 12% is. It's 12 of 100. 12 of 100 actually sort of implies that it's kind of like a ratio. 12 to 100. In fact, that's actually a really neat observation that's going to be important for us to understand exactly how to manipulate and work with with percentages. So percentages somehow connected with ratios, and that's the key. In any case, here is a sort of a visualization of what 12% means. It means 12 of 100. There we have it. The percent.
All right, so let's continue on. So let's look at this problem. Rob's fruit farm consists of 100 acres on which 3 different types of apples grow. On 25 of the acres, the farm grows Empire apples. Macintosh apples grow on 30% of the farm. The remainder of the farm grows Fuji apples. Shading the grid below to represent the portion of the farm each type of apple occupies. Use a different color for each type of apple. Create a key to identify which color represents which type of apple. So I'm going to start Empires. I'm just going to say they are red. So let's look. It says what? It says this for my Empires. 25 acres are on Empires. So what does that mean? 25 out of 100. So that's going to be 25%. So I need to shade in 25 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going to do the same thing here, all the way up to 20. And then I'm going to have 1, 2, 3, 4, 5. So what is my part to whole? Well, my parts is I've shaded 25 in out of what? Out of 100, since it's a 10 by 10 diagram. Okay, let's go to Macintosh. Macintosh, I'm just going to say they're going to be green. And my part to whole is what? Well, let's look back at my problem. There's 100 acres, and it's 30%. So that means it's going to be what? 30 out of 100. So I'm just going to do the same thing. I could start right underneath. I'm going to start on the other side, though. Now let's see if it makes a difference. 1, 2, 3. And I'm going to do this for 3 rows, since 3 times 10 is 30. Alright, so now let's move on to my last one. The last one is what? My Fiji apples. There's a problem here though. It doesn't tell me how many Fiji apples I have. It says the remainder of the farm grows Fiji. So what can I do? Well, my remainder is whatever I haven't shaded in. So that means everything else is going to be Fijis. I'm going to have to do some tiny bit of math to figure out how many there are, but it's not going to be that difficult. What I could do is I could count every single purple box. That's going to take me a little longer. So what I'm going to do is I'm going to count how many complete rows I've shaded in, multiply that by 10, since each row is 10, and then add my impartial or not complete rows. So let's check. I have 1, 2, 3, 4 complete rows times 10 plus my partial. So 1, 2, 3, 4, 5. So what does this equal? That equals 40 plus 5, which is what? 45 parts out of 100. Alright, let's move on to our next one, our next video.
Alright, let's take a look at an example that involves a percent. So let's write 60% as a fraction in simplest form. Remember, we just saw that in fact we can think of a percent as a ratio, as a fraction, and now let's start studying it that way. So, what do we have here? 60%. Well, that means 60, a ratio of 60 to 100. So we have 60 over 100 as the fraction. And now I want to write that in simplest form. So let's see if I could simplify it. Well, I could divide the numerator by 10 and then the denominator by 10. And I'll have an equivalent fraction, so I'll simplify it. What do I get? In the numerator I see 6. In the denominator I'd see 100 divided by 10, which is 10. Is that in simplest form? It's certainly much simplified, but is it in fact in simplest form? Well, actually, no, because actually I can divide both the numerator and denominator by 2. And then I see that that fraction is equal to 3 over 5, and I think that is in simplest form. So 60% as a fraction actually can be represented in simplest form as 3/5, or 3 over 5. Neat. Percent, fraction. There's a connection.
Alright, let's continue on. So here we have a different problem. The shaded portion below represents the portion of a granola bar remaining. So we have some kind of granola bar that we start out with, and I've eaten a tiny portion of it. My shaded part is whatever I have left. So what percent does each block of granola bar represent? So each part is looking at each individual portion, so each individual square. So what percent does each block represent? Well, here, this is what we used when we were working back with what? Back with decimals. So remember, with my decimals, each tiny part, we're working up towards one whole. So each tiny part is 0.01, and there's 100 of them required to make a whole. So if I look back on my chart like this, let's look. What would this be? Well, I have it filled all the way up to here. So that's going to be 80%. I can also count, go 1, 2, 3, 4, all the way up to 80. But each block is 1%. Now what percent of my granola bar remains? Well, this one's almost as easy as that last problem. There's 1 row, 2 rows, 3, 4, 5, 6, 7, 8. So there's 8 rows. Each row has 10 in it. So this would be 8 times 10 equals 80. But I'm looking at it as a percent, parts out of 100. So I just need to add what? I just need to add that percent sign to it. What other ways can we represent this percent? So what other ways can I use this model to show a relationship? Well, I could do 80 out of 100. I could do 0.8. I could reduce this fraction so that it is 4/5. I could reduce it so that it is 8/10. These are all ways to show this model. However, the only way to write as a percent is this. Decimals, I could keep adding zeros onto it. For my fractions, I could simplify or expand, but my percents, there's only one way to write it, is at 80%. Alright, let's watch our next video.
Let's take a look at an application together. A baby's body can be as much as 75% water. That's a lot. And what we want to do is write 75% as a fraction in simplest terms. All right, well, 75%. Well, that's a fraction, 75 over 100. Well, now let's see what happens if we now try to write this in simplest form. Well, what I can do is I can divide the numerator by 25 and the denominator by 25, and I get an equivalent fraction. And what would I see? In this case, I would see 75 divided by 25 is 3. 100 divided by 25 is 4, and so I see 3/4, which is in lowest terms. And so I see that 75% is equivalent to 3/4. Again, we're seeing a connection between percent and fraction. Percent, fraction, percent, fraction. And the connection is we have 75 over 100. The denominator always starts off to be 100.
Alright. And let's watch one more video.
All right, let's take a look at this question. Let's write 32% as a decimal. So what does 32% mean? Well, we could think of it as a fraction, 32 over 100. So I have 32 over 100. And now, actually, I can divide and see what I get. So to see what this equals, I take 32 and divide by 100. So I put my decimal here. I've got an army of zeros waiting on reserve in case I need them. And let's see if I need them or not. So I put the decimal point right up there above it. And I see 100 goes into 3 0 times. 0 times 100 is 0. I subtract and I get 0, so I basically just have the 3 here. Bring down the 2 and I see 32. 100 goes into 32 0 times. 0 times 100 is 0. And when I subtract, I see 32. Now I bring down one of my reservist zeros. So now I have 320. Now we're going to have some fireworks. Because 100 does go into 320. It goes in 3 times. 3 times 100 is 300. And when I subtract now, I see 20. Bring down an extra reservist. I have 200. 100 goes into 200 twice. 2 times 100 is 200. I subtract. I see 0. That tells me that I'm done. I finished. And I see my decimal expansion. I see that 32% is the same thing as 0.32. And that's kind of a not so surprising coincidence, really, that the digits 3, 2 appear in both. That, in fact, is something we're going to see as a recurring theme. So to get from 32 as a percent to a decimal, all we did was put a decimal point 2 units to the left to where the decimal point was before. Neat. 32% equals 0.32 as a decimal. Again, we're seeing a connection between percents and now decimals.
So here we're just learning the relationship between percents, fractions, and decimals. Alright, now what you have here is, look at that amazing typo. What you have here is you're going to work on these problems in your notebook. I'm going to have you guys work on them independently or with a partner in your level 1 voices. When you're done, go to the next page.
Here's a fun example I want us to take a look at. 25% of the pets in Samantha's neighborhood turn out to be fish. I want us to write 25% as a decimal. So let's think about this. Fish, so we should use a watercolor. So we have 25%. That means we can write as a fraction 25 over 100. Well, what does that mean? Well, that fraction actually tells us that we actually have a division question. We actually have 25 divided by 100. And that equals 0.25. And so 25% as a decimal is 0.25. And again, we're seeing some kind of pattern. That when we go from a percent to a decimal, it seems as though we take this decimal point that's here on the right and move it 2 units over to the left. And that's how we seem to be getting this decimal representation for this percent. A neat observation, but we see the 2 and the 5, and we see the 2 and the 5. It's just the placement of the decimal point that really is at stake here. Anyway, you can see that we can take a percent and convert it to a fraction. We can take a percent, we can convert it to a decimal, and both of those will be really valuable, useful, and important when we're taking a look closer at what percents mean. I'll see you there.
Alright, we're almost finished. So closing, what are 3 things you learned about in this lesson? Share 2 ways that you can write 2%. And what was one thing that you still want to know about from this lesson? Alright, lesson summary. Percent means out of 100. Therefore, percents are fractions with a denominator of 100. So whenever I have a fraction with a denominator, that bottom part is 100, I can take it and rewrite it as a percent. We can create models of percents. One example would be to shade a 10 by 10 grid. Each square in a 10 by 10 grid represents 1% or 0.1, like our granola bar example. Alright, exit tickets. You're going to complete this in your notebook, and then you guys are good to go on to Khan Academy. On Khan Academy, complete 2 lessons. Then you may play math games. Alright, good luck.